Hi everyone, and welcome to Fact Science, the channel where we explore the most amazing facts about our universe. Today, we're diving headfirst into the mysterious world of black holes. Get ready to have your mind blown because we're about to uncover 25 fun facts about these cosmic giants. From their unimaginable gravity to their mind-boggling effects on time and space, black holes are some of the most fascinating objects in existence. So, buckle up, space explorers, and get ready for an exciting journey into the heart of darkness.
First things first, what exactly is a black hole? Imagine a place in space where gravity is so strong, so intense, that absolutely nothing can escape its grasp. Not even light, the fastest thing in the universe, can break free from a black hole's gravitational pull. That's why they're called black holes. No light can escape to illuminate them. It's like a cosmic vacuum cleaner, sucking in anything that ventures too close. But don't worry, we're a safe distance away from these gravitational monsters.
The idea of a black hole might seem like something out of a science fiction movie, but it actually dates back centuries. In 1783, long before we even had the technology to study them, an English scientist named John Michell first proposed the concept. He called them dark stars, and he imagined these objects as being so massive that their gravity could trap light itself. Michell's ideas were incredibly ahead of their time, and it wasn't until much later that scientists began to take the possibility of black holes seriously. But his work laid the foundation for our modern understanding of these incredible objects, proving that sometimes the most groundbreaking discoveries begin with a spark of imagination.
We've talked about how black holes are regions of space-time where gravity is super strong, so strong that nothing, not even light, can escape. But did you know that black holes come in a variety of sizes? It's true. Some black holes are just a few miles across, while others are billions of miles in diameter. Imagine a black hole the size of a city, like New York City. Now imagine another black hole the size of our entire solar system. That's how different in size black holes can be. It's pretty mind-boggling.
Okay, so we know black holes are out there, lurking in the vastness of space. But how close is the nearest one to Earth? Well, it's not exactly in our backyard, but it's closer than you might think. The closest known black hole to Earth is called V616 Monocerotis, also known as a 062000. It's located about 3,000 light-years away from us in the constellation Monoceros. That might sound incredibly far away, and it is, but on the scale of the universe, it's practically a stone's throw. To give you some perspective, 1 light-year is the distance that light travels in 1 year. That's about 5.88 trillion miles. So even though 3,000 light-years might seem like a safe distance, it's a reminder that black holes are scattered throughout our galaxy. But don't worry, even though V616 Monocerotis is the closest known black hole to Earth, it doesn't pose any threat to us. It's not on a collision course with our planet, and it's far too distant to have any noticeable gravitational effects on our solar system.
How do these mysterious objects form in the first place? The story of a black hole begins with the birth, life, and death of a star. Stars are born in giant clouds of gas and dust called nebulae. Gravity pulls this material together, igniting nuclear fusion. Eventually, every star runs out of fuel. Without fusion, gravity takes over, causing a supernova. And that, my friends, is how a black hole is born.
Did you know black holes come in different sizes? It's like comparing a basketball to a house to a planet. Astronomers classify black holes into stellar, supermassive, and intermediate types. Stellar black holes form when massive stars collapse under their own gravity. Supermassive black holes are millions or billions of times the mass of our Sun. They lurk at the centers of galaxies, including our Milky Way. Intermediate black holes might form from star collisions in dense clusters. Remember those supermassive black holes we talked about? They're not just sitting around doing nothing. Astronomers believe that these gravitational giants play a crucial role in the formation and evolution of galaxies. Think of a supermassive black hole as the anchor of a galaxy, holding everything together with its incredible gravity. As gas and stars swirl around a supermassive black hole, they form a giant, rotating disk called an accretion disk. The material in the accretion disk heats up as it gets closer to the black hole, releasing enormous amounts of energy in the form of light, X-rays, and other radiation. This radiation can be so powerful that it can outshine all the stars in the galaxy combined. But supermassive black holes aren't just about destruction. The energy and material they release can also influence star formation and shape the overall structure of a galaxy. They're like the ultimate cosmic architects.
Get ready to have your mind blown because we're about to meet the heavyweight champion of black holes, Ton 618. This cosmic monster is so massive that it makes our sun look like a tiny speck of dust. How massive are we talking? Hold on to your hats, because Ton 618 weighs in at a staggering 40 billion times the mass of our sun. It's so big that if it were at the center of our solar system, it would swallow up everything out to beyond the orbit of Pluto. To put that into perspective, imagine trying to squeeze all the sand on all the beaches on Earth into a single grain of sand. That's how dense Ton 618 is. It's mind-boggling to think about how something so massive could even exist. Ton 618 is a type of black hole called a quasar, which means it's incredibly bright and active. It's so bright, in fact, that it outshines its entire host galaxy.
Black holes are already mind-blowingly massive, but can they get even bigger? You bet they can! Just like two drops of water merging into one, black holes can collide and combine in a spectacular cosmic dance. Imagine the immense gravity of two black holes pulling on each other, spiraling closer and closer. As they get closer, they start to orbit each other faster and faster, sending out ripples in space-time called gravitational waves. Finally, they crash together in a powerful collision, merging into one even more massive black hole. This process releases an unbelievable amount of energy, more than all the stars in the universe combined.
Alright, explorers, imagine approaching a black hole. As you get closer, you'll encounter a boundary called the event horizon. This is the point of no return, a region where gravity is so strong that nothing, not even light, can escape its pull. Think of it like a waterfall. Once something goes over the edge, it's nearly impossible to climb back up. It's the same with the event horizon. Once something crosses it, it's trapped inside the black hole forever. We can't see anything beyond the event horizon because no light can escape to reach our telescopes. It's like trying to see through a wall. Anything behind it is hidden from our view.
Hold on to your hats because things are about to get really weird. One of the most mind-boggling things about black holes is their effect on time. You see, according to Einstein's theory of general relativity, gravity can actually warp time. The stronger the gravitational pull, the slower time moves. And since black holes have the strongest gravitational pull in the universe, time near a black hole slows down significantly compared to time here on Earth. Imagine you could send a spaceship close to a black hole while you stayed back on Earth. As the spaceship got closer to the event horizon, you would see their clocks ticking slower and slower. To them, everything on board would seem normal, but to you, it would look like they were frozen in time. Although we can't travel to a black hole yet, this effect has been measured and proven right here on Earth with our very precise atomic clocks.
Black holes are mysterious objects, and one of the things that makes them even more fascinating is that they can spin. Just like a basketball spinning on a player's finger, a black hole can rotate on its axis. But here's the really cool part. A black hole's spin isn't just some random fact. It actually affects the space around it. Imagine stirring a pot of soup. The spinning spoon creates a swirl in the liquid. Similarly, a rotating black hole drags space-time along with it, creating a swirling effect called frame dragging. It's as if the black hole is constantly stirring the fabric of the universe. And this isn't just a theory. Scientists have observed the effects of frame dragging around black holes, proving that these cosmic giants can indeed spin.
We usually think of black holes as giant vacuum cleaners, sucking up everything around them. And while it's true that their gravity is incredibly strong, some black holes are also known to burp. Okay, not exactly burp, but they do sometimes emit powerful jets of particles and radiation. These jets, some of which can stretch for millions of light years, are thought to be fueled by the intense energy present around a black hole. As matter spirals inwards towards the event horizon, it heats up to extremely high temperatures. This superheated material creates a magnetic field, which acts like a particle accelerator, launching particles and radiation outwards at nearly the speed of light. These jets are so powerful they can actually influence the evolution of entire galaxies.
Black holes are often described as being hungry, and for a good reason. They have an insatiable appetite for anything that gets too close, including stars. You see, when a star wanders too close to a black hole, the immense gravitational pull can start to stretch and distort the star. This is where things get really interesting. As the star gets pulled closer, the difference in gravity between the side of the star facing the black hole and the side facing away becomes more and more extreme. It's like pulling on a piece of taffy. The star gets stretched out into a long, thin strand, a process scientists dramatically call spaghettification. Eventually, the star can no longer hold itself together and gets completely devoured by the black hole.
Black holes are known for their incredible gravitational pull, and if you got too close, you'd experience something called spaghettification. Imagine a giant plate of spaghetti, and you're being pulled from one end. As you approach a black hole feet first, the gravity pulling on your feet would be much stronger than the gravity pulling on your head. This difference in gravitational force would stretch you out, much like we stretch out dough to make pasta. This stretching effect, spaghettification, happens because of the extreme tidal forces near a black hole. Tidal forces are the difference in gravity's pull on different parts of an object. And trust me, you wouldn't want to get caught in a black hole's spaghetti-making machine.
Black holes are invisible, right? So how do we even know they're out there? Well, it's like detective work. Even though we can't see black holes directly, we can observe their effects on the objects around them. One way is by looking for stars behaving strangely. If a star orbits an invisible point in space at super high speeds, it's a big clue that a black hole's gravity might be responsible. It's like a cosmic game of tug-of-war. Another way is by observing the light from nearby stars or gas clouds. As matter gets pulled towards a black hole, it heats up and emits intense X-rays. By detecting these X-rays, scientists can infer the presence of a black hole. For a long time, black holes were just a theory, a mind-blowing concept predicted by Einstein's equations. But in 2019, scientists made history by capturing the first ever image of a black hole. This wasn't easy. It took a global network of telescopes called the Event Horizon Telescope, working together to achieve this incredible feat. Imagine trying to take a picture of a donut on the moon from Earth. That's how challenging it was. This image wasn't just a pretty picture. It provided the first direct visual evidence of the existence of black holes and confirmed many of our theories about these mysterious objects. It was a landmark achievement in astronomy.
We usually think of black holes as these giant vacuum cleaners of space, sucking up everything in sight. But did you know that even black holes don't last forever? It's true. They actually evaporate over a very, very, very long time through a process called Hawking radiation. Hawking radiation is named after the brilliant physicist Stephen Hawking, who first proposed this idea. It all has to do with the weird world of quantum mechanics, where tiny particles are constantly popping in and out of existence. Sometimes these particles pop up right at the edge of a black hole's event horizon. If one of these particles escapes, it can carry away a teeny tiny bit of the black hole's energy with it. Now, this energy loss is incredibly small, like trying to empty an ocean one drop at a time. But over incredibly long periods, like billions of trillions of years, even a black hole can eventually radiate all its energy away.
Black holes are like extreme science labs in space. Studying them helps scientists like me understand some of the most fundamental laws of physics, things like gravity, time, and the nature of reality itself. It's like trying to solve the universe's biggest puzzles. For example, black holes push Einstein's theory of general relativity to its absolute limit. This theory describes how gravity works, and black holes are where gravity is at its most extreme. By observing black holes, we can test if Einstein's theory holds up in these intense environments, or if we need new physics to explain what's going on.
Over 100 years ago, Albert Einstein, a genius scientist, came up with this mind-blowing idea called the theory of general relativity. It totally changed how we think about gravity. He said it wasn't just a force, but a warping of space and time caused by massive objects. Now, get this, black holes were one of the most bizarre predictions of Einstein's theory. At the time, people weren't even sure if black holes were real or just some crazy mathematical idea. But guess what? Einstein's theory was right. Decades later, astronomers started finding incredible evidence of black holes out there in the universe, just as Einstein's theory predicted.
Black holes are already mysterious enough, but what if I told you they might be even weirder than we thought? Some scientists believe that black holes could be portals to other universes. It's like something straight out of science fiction. This idea comes from the fact that the singularity at the center of a black hole is a point of infinite density. Imagine everything crammed into such a tiny space that the laws of physics as we know them break down. Some theories suggest that this breakdown could create a bridge, a wormhole, connecting our universe to another. Now, we haven't actually seen a wormhole, let alone traveled through one. It's still very much in the realm of theoretical physics. But the possibility is so intriguing that scientists are actively researching it.
We've all heard the saying, time flies when you're having fun. But near a black hole, time doesn't just fly, it warps and bends. This is one of the most mind-boggling consequences of Einstein's theory of general relativity. You see, gravity isn't just a force, it's a curvature in the fabric of space-time. Massive objects like black holes create a kind of dip in this fabric. And the closer you get to the black hole, the steeper the dip, and the slower time runs relative to someone farther away. Imagine you could hover just outside the event horizon of a black hole while a friend stayed safely back on Earth. Time would pass much slower for you compared to your friend.
At the heart of every black hole lies a mind-blowing enigma, the singularity. This isn't just a place of extreme gravity. It's a point where density becomes infinite, and the laws of physics as we understand them completely break down. Imagine taking all the matter in a star, even a star hundreds of times bigger than our sun, and squeezing it down to a single point with no size. That's the singularity, an infinitely small point containing an unimaginable amount of mass. We can't observe the singularity directly, because nothing, not even light, can escape the black hole's gravitational pull once it crosses the event horizon. So what exactly happens at the singularity remains one of the biggest mysteries in astrophysics.
Black holes aren't just cosmic vacuum cleaners, you know. They're more like influencers of the universe. We've learned that supermassive black holes live at the center of most galaxies, and our own Milky Way is no exception. These black holes are huge, and their gravity is so strong that they can actually influence the formation and evolution of entire galaxies. It's like a cosmic dance, with the black hole's gravity guiding the movements of stars and gas clouds over millions and billions of years.
Even though we've come a long way in our understanding of black holes, there's still so much we don't know. Every new observation, every new simulation brings up more questions than answers. For example, we're still trying to figure out exactly how supermassive black holes form. Do they start small and grow over time, or are they born from gigantic clouds of gas collapsing in the early universe? And what about those mind-bending theories about black holes being portals to other universes? The possibilities are enough to make your head spin faster than a black hole. But that's what makes studying space so exciting.
Well, there you have it. 25 fun facts about black holes. Which one blew your mind the most? Was it the fact that black holes can warp time and space? Or maybe that they come in different sizes, some even billions of times the mass of our sun? Let me know in the comments below, and remember, keep looking up and never stop exploring the universe around us.